Good day everyone, I am Lee Chen E. So this is my assigned lab 2 for CompBio 2. So without further ado, first of all, the title is An Extensive Benchmark Study on Biomedical Text Generation and Mining of ChatGPT. So as you can see, the authors are TJ Chen et al. The journal publishes the publication year 2023, still not that old, and the affiliations, etc. And we do have the input data, which is BLURB benchmark. So BLURB is the abbreviation for Biomedical Language Understanding and Reasoning Benchmark. So we have these task types, which has NER, name entity recognition, equal extraction, biomedical relation extraction, BRE, sentence similarity, document classification, and question answering, QA. So we have different data sets for the task types, and we have the metrics to kind of like evaluate the task, like F1 for NER, micro F1, Pearson R for sentence similarity, and etc. So the methodology follows with 4 steps. First, prompts are carefully engineered. Each prompt contains a background context, a task instruction, and an output constraint. The researchers tested both simplified and complex prompt designs. Second, ChatGPT is built on GPT 3.5 is evaluated in a zero-shot or one-shot manner, which means no fine-tuning is performed at all. Third, since ChatGPT is a generative model, a post-processing step checks whether the output follows the required format. If not, a correction prompt is sent automatically. Fourth, the BLURB score is computed as an average across all 6 task types, and ChatGPT, which serves as a benchmark, is then compared against 3 fine-tuned, which is biomedical BERT baseline. We have PubMed BERT, BioLink BERT base, and BioLink BERT large. The last of which has like over 325 million parameters. And for example, I'll prompt a question to ChatGPT. In clinical trials, does the H3R antagonist CEP26401 have a positive effect on cognition? Answer with a yes or no. And answer of ChatGPT would be like, clinical proof of concept for CEP26401 in cognition enhancement has not been reported yet. Therefore, I cannot answer with a yes or no, as there is no conclusive evidence from clinical trials. So it fails to do so in the true false yes no. So follow after step 4, we'll be discussing about the outputs and the results. As you can see, ChatGPT has a relatively low score of 58.5 compared to the 3 other ones, which has over 80 at least. And let's discuss about the task. Let's say NER, ChatGPT has an output of 48.27 compared to the best baseline of like 86 plus. So as you can see, ChatGPT performed poorly compared to the best baseline, except for question answering, where ChatGPT has a very close results of like 82.51 compared to the best. It's like almost a gap of 1 only. So ChatGPT's chatbot is designed to naturally transferring to QA task for relation extraction, one-shot prompting on CamProd improve the score from like 34 to 48, showing that prompt engineering has a meaningful impact. So yes, the limitations and the gap. So first, ChatGPT cannot be fine-tuned, making a comparison with fine-tuned baselines inherently unfair. Second, ChatGPT free-form generative output frequently violates the structured format that benchmark metric required. Third, the study was conducted on GPT 3.5 only, which was like a 3 years ago model, where GPT-4 wasn't available yet, which likely underestimates the ceiling of LLM performance. And fourth, ChatGPT was trained predominantly on general web text, leaving rare biomedical terminologies underrepresented. Additionally, the false positive rate for CamProd reaches 75%, and systematic prompt optimization was not explored across tasks. So based on the limitations, I've proposed 3 improvements. So first is the parameter efficient fine-tuning, second is the retrieval augmented generation with PubMed, and third is the structured output via JSON mode and post-parsing. So I would like to add on a bit on the second one. So it's like augmented generation with a live part-map retriever to inject relevant biomedical context at inference time, where it can compensate for the domain knowledge gap without any retraining. So it saves time and it saves the computing power to regenerate. Okay, to summarize, ChatGPT shows strong potential in biomedical QA, but it falls significantly behind fine-tuning models. In structured tasks like NER and relation extraction, this too is the most significant one where the scores are low. So the key bottlenecks are generative format mismatch and absence of domain-specific fine-tuning. So as you can see, these are the full APA citation which I listed here. Thank you very much. Thank you all.